Dear friends, today we are dealing with the topic integration. Mathematics integration was found out by a renowned scientist Riemann. In this class we are dealing with sigma notation for finite sums. We use the capital Greek letter sigma, which is written as SIGMA in English, to write an abbreviation for a finite sum. What do you mean by a finite sum? Finite sum A1 plus A2 plus etc. plus An is denoted by sigma k equals 1 to n ak. Ai's are the terms of the sum. A1 is the first term, A2 the second one, and ak the kth term. An is the nth and the last term. The variable k is called index of summation. Now, for the values of k, they run through the integers from 1 to n. The number 1 is the lower limit of integration and number n is the upper limit of summation. So, the lower limit of summation need not be always 1 also. It can be any integer. The formula generating the terms changes with the lower limit, but always the terms remains the same. Now we deal with illustrative examples. The first example, sigma k is equal to 1 to 5 k square. We will put k is equal to 1 square, then k equals 2 square, plus 3 square, plus 4 square, plus 5 square, that is 1 plus 4 plus 9 plus 16 plus 25 equals 55. The second example, sigma n is equal to 1 to 3 minus 1 raised to n into n plus 1. It is equal to minus 1 raised to 1 into 2 plus minus 1 raised to 2 into 3 plus minus 1 raised to 3 into 4, that is minus 1 into 2 minus 2 plus 6, that is plus 4 plus minus 12. So, it is minus 8. Third sum, k equals 2 to 4 k by k plus 1. We will write as usually k equals 2 first, 2 by 2 plus 1, then plus k equals 3 by 3 plus 1, then k equals 4 by 4 plus 1, that is 2 by 3 plus 3 by 4 plus 4 by 5. The LCM 60, when you do the problem, you will get 133 by 60. Now, we see about some important properties of summation. We can use these properties whenever we work with finite sums. The following properties are not proved here, but it could be proved by mathematical induction, and it is left as an exercise for you, dear students. The first one, sigma k equals 1 to n ak plus bk, that is equal to sigma k equals 1 to n ak plus sigma k equals 1 to n bk. It is called in general sum rule, SUM, that is addition rule. Second one is a difference rule or subtraction rule, that is k equals 1 to n ak minus bk, that is equal to sigma k equals 1 to n ak minus sigma k equals 1 to n bk. The third one is called constant multiple rule, that is sigma k equals 1 to n c into ak is equal to c into sigma k equals 1 to n ak. Here this c is a constant. Next one is called constant value rule. The fourth one, sigma k equals 1 to n c, that is you are repeating the number c n times, that is equal to n into c. Next one is a very simple thing, but it is a bit difficult to understand. Just listen, if m is less than or equal to n and n plus 1 is less than or equal to p, means you are assuming two numbers m and n. M is a number which is less than or equal to n and we are assuming that n plus 1 is another number which is less than or equal to p. Then how can you split this sigma I is equal to starting from m and ending with p a I. That is, the numbers from m to p, sigma I is equal to m to n a I plus sigma I is equal to n plus 1 to p a I. That is, you are splitting the numbers. If it is for an example, sigma I is equal to 1 to 5 a I, you are splitting it into 2. Sigma I is equal to 1 to 2 a I plus sigma I is equal to 3 to 5 a I. Both means a1 plus a2 plus a3 plus a4 plus a5. The sixth one, sigma I is equal to m to n a I, it is equal to c into n minus m plus 1, where c is a constant. Sixth one, a I is equal to c, and for all I, the values of I ranging from m to n. So, this is a formula which you have to learn by heart in order to do some problems. The sixth one, sigma I is equal to m to n a I is equal to c into n minus m plus 1, where c is a constant. The seventh one, if a I plus less than or equal to b I for all I, m is less than or equal to I less than or equal to n. In the seventh property, we are saying that sigma I is equal to m to p a I, it is less than or equal to sigma I is equal to m to p b I. So, we have dealt with all the properties, all the 7 properties. In the next class, we will see about more. Thank you, students. Bye.